Logical Volume Manager, or LVM as it's more commonly referred to, is kind of like a SAN environment set up on Linux software. It's really cool. It's like you have your own storage area network, but it's just using software on your Linux machine. Now, there's some terms that we have to learn and, have to set up our partitions, etc. And there are some real things you have to watch out for. But setting up LVM is easy. The tough part is understanding what on earth is going on. And thankfully, it's not that complicated once you really get a feel for what's going on. So there are three parts of LVM. There's the physical volumes, or PV, a volume group, VG, and a logical volume, or LV. And the graphics here kind of show what those things are. The physical volumes are just that, physical volumes or data storage devices. These can be hard drives, like actual physical hard drives, or they can be RAID partitions or RAID arrays that will protect your data. And remember I said that there's a danger or a gotcha with using LVM? One of the real important things to realize is that if you use strictly LVM on raw hard drives, if a single drive fails, your entire LVM is going to be messed up. So really, if you're doing something in production, you're going to want the physical volumes inside of your LVM, infrastructure to be protected, to be like RAID devices, to be mirrored, to have protection built into the physical volumes themselves, because LVM doesn't offer any sort of striping or parity or anything like that. Now, the reason that you would still do that is because the LVM system does some really awesome things. Basically, you take all of your physical volumes, whatever they might be. In our case today, they're going to be hard drives because that's the simplest way to do it. But again, you're going to want RAID if it's going to be a production environment. But all of these physical volumes are kind of shoved together into something called a volume group, which is like just a big bucket of available data. So here I have a 10 gig RAID, 10 gig drive, 10 gig drive. So altogether, if we used all these physical volumes and made a volume group, we would have 30 gigabytes of raw storage in the bucket. But you don't directly access this storage. This is just kind of like a bucket of data. And what you do is pour some out or slice a piece off of your volume group and create a logical volume. And then this logical volume is kind of like a hard drive. So this on your system is going to be represented as a device that you would then format and you would use, with a file system. So the logical volume is the end device that you actually work with. And why would you go through all of this trouble to put devices together only to slice off pieces of devices? Well, it's because LVM offers some really cool things. You can add a physical volume to an existing volume group. So let's say you needed more than 30 gigs of storage. You could add another hard drive to that, and then this is going to expand a little bit, and all of a sudden now you have 40 gigabytes of storage instead of just 30. And you can do this without changing any of the other things like the logical volumes. And the same thing can be done to logical volume. Let's say you said, you know what, I thought 5 gigabytes was going to be enough. Turns out it's not. So I'm going to expand this so that this is now 10 gigabytes. And with the file system on it, you can actually expand the logical volume in real time while it's on your system running. It's really amazing. So it may seem like a lot of complicated layers that we're adding on top of our data structure, but that flexibility makes it awesome. Now, in order to use this, we do need to create some partitions on our drives. And so we're going to do that now. We set them up kind of like we would for a RAID system, but just slightly different. So let's go and set up our drives for an LVM infrastructure. Now on my Ubuntu box here, if we type lsblk, we're going to see that we have some devices down here. We have SDB, SDC, and SDD, which are all 10 gigabyte hard drives that we're going to put in. Now we're going to use actual disks in our LVM system for physical volumes, even though, like I said, RAID is ideal in that situation. But these are going to be our three, but we need to create partitions on there. Notice I'm already root. I'm going to say fdisk dev SDB. Now I'm going to go through and create a partition really quickly. So I'm going to say a new partition, primary partition, default of 1, first sector sure, last sector default, maximum size. So it's created a partition with 10 gigabytes, but I want to change the type of the partition. So I'm going to press T. Now, if you don't know these commands, just press M and it'll list out our commands. But I just know that T is now how we're going to select our partition type. Let's type an L so we can see all the options available. And what we want to do is create type 8 8E, which is Linux LVM. All right, so I'm going to say 8E, press enter. So now the partition has been changed to Linux LVM. Going to write that to disk. We'll do the same thing for the other disks on our system. All right, and now if we do lsblk, we're going to see we have 3 partitions here as well. And that's what we're going to use to create our LVM system. And I'll just reiterate quickly that the danger with LVM is that you don't want to actually use hard drives as your physical volumes. You want them to be something safer, because if one fails, then the whole thing falls apart. But in our example, we are using drives because it's the simplest way to show how things work. I hope this has been informative for you, and I'd like to thank you for viewing.